Hi there, Sixes. So I heard a bunch of people had a lot of trouble with this, and that's totally fine. I just figured then let's take some time and just talk through it and see what I was looking for and expecting you guys to answer. So we're looking at statistical models and determining like what's wrong, like how they've been represented deviously, or like they're hiding the truth, they're lying. So how does that happen? And I hope you guys liked the video on the Iditarod. The Iditarod is a super interesting race because it's like some of the toughest people in the world doing one of the hardest races in the world every year. It's cool. And you can see the prize money is quite good also. So Haley made this graph of the prize money, and Tiffany finds that she thinks this graph is wrong. There's something messed up about it. So what can we say that's wrong about it? There are a few things that have been pointed out to me by different students, and I would say I think there's only one thing that I see which I would say is wrong. The other things I see could be better and worse. So some people were telling me instead of this lining directly over the middle here, they were saying that's strange. Like that means either this mark should not be there and it should be like over here, showing that the year is occurring there in the middle. Another fix that I would do for that, because I think that's fair, I just don't like the fact that they used like a dot graph of this or a line graph of this. I think it should be a bar chart. And if we made bars, they go to the height of those dots there, then I think this graph is like better. I think it's clearer. But there's still something I really, really don't like about it. Like I would say is wrong. And the heart of what it is, you can see when you think about, let's see, let's look here and think, okay, that's like it's an increase. So how much is that increase? Okay, it's a little over $100,000. That makes sense. This decrease is huge. That's crazy. How big is that decrease? Well, that's over $300,000. But does this decrease look 3 times as big as this? Like when I compare the vertical distance that happened here, and then I try to think of, okay, let's do that vertical distance 3 times, I end up in a very different place than this person did, like way, way lower than they did. So why does that happen? Well, it happens because this is an issue. They've used not constant intervals. So the vocab for this will be constant intervals are super important. So what does constant intervals mean? It means that the space here that represents $100,000 should be the same as the space here that represents $100,000. This is a problem because it's crossing $200,000, means this $900,000 needs to be in the middle. It's a serious issue if it's not. It means your graph is not displaying reality. It's displaying some random amount depending on like how much the spacing is over here. So make that spacing even, or use constant intervals. That's important. So that is some of the things I was thinking and looking for down here. Like Haley's graph is misleading. Can you describe how? Yes, I can. I can describe how by saying, come on. She didn't use constant intervals. That's the problem. So why is it an issue? That means the space that the numbers grow and drop is false. And I don't mean the actual numbers are probably true. It seems like she researched these numbers and they're probably true, but the space that they move is false. And it's because intervals are about making sure that that space represents the numbers. So that's the type of thing that I was thinking there. We come down. Good. What was I thinking here? We're talking about the fact that sometimes, why won't it let me throw this away? Sorry. Okay, done. Good. So graphs give visual pictures of data. Great, you guys know this. Sometimes companies try to sell more of a product, so they want misleading graphs to make sure that you buy more of their product. That makes sense. It's smart for them as a company, but it means we need to be intelligent, educated people. Companies also do this with purchases, showing that a percentage of people like their product better than another one. That makes sense. Toothpaste companies do this commonly. They say like 80% of doctors recommend our toothpaste. Well, but 80% of doctors could recommend your toothpaste and another toothpaste and another toothpaste. Doctors can recommend all these toothpastes. So we can be misleading about our data. So your answer in graph in number one shows one way graphs can be misleading. However you answered there, you have an answer that you can use to make sure you don't fall into the same traps. What I was thinking, if you talked about constant intervals, then you can always double check the space between the numbers on the axes. That's how we catch that. You definitely want to double check your graph, obviously, but it's hard to know what you're double checking unless you're looking for something specific. In this case, look at the space between the numbers on your axes and make sure it's even. Then you'll avoid that mistake. Great. So next thing, this is super annoying to me. It won't let me just, whatever, done. Okay, so we've got survey about people's favorite fruit. And I'm saying one of these I think is clearer and better. Which one? Well, you could probably, in this case, make an argument about which one is more reliable, and you could probably argue either direction. I'm going to argue, well, I guess first I would look for differences. The difference I see is when I look here, this guy is counting by hundreds, and that's totally fine. This guy is counting by 25s when I look at these, which is more granular, we'd say. So this isn't about constant intervals. This is about like the interval here equals 25, and the interval over here, the y interval specifically, come on, tools. Y interval here equals 100. So that's the difference between the two graphs. So then the question is, which one is better in this scenario? I think the easiest way for me to determine that is by looking at the top of these first two graphs. Like I can see much clearer here. This was probably at 375 or 374, and this raised like maybe that's 5 fruits more, and there are 5 people more that like oranges. They're very close either way, but here, does that look like a space of 5? I think it's harder to tell. Like here I can kind of tell, here I really don't know. That could be 25 for all I know. So for me, I choose this graph. I think the interval of 25 displays this situation better, but it's really only because I can tell the increase here much better than I can on the other side. So that's the type of thing I was looking for here, and you can go ahead and fill it in. Good. Ashley is asking people in 8th grade if they've eaten pizza. Come on. Oh, there we go. Okay, good. So have you eaten pizza this week? I was surprised how many people were confused, but I bet you would not be confused if you looked at this question. So have you eaten pizza this week? She's got like 112 or so are saying yes. Oh yeah. Oh, hold on. That's 84%. So why is it up here? There's big issues there. It's what tips me off is as soon as I'm interpreting this and I get over and see here percent, then I know we're in trouble. 84% and 16% are reasonable. Those make 100%. But this is definitely not 84%. And this is definitely not 16%. This is like down here at, I don't know, 3% or 4%. And this one's like 112. Like these are issues. So this one should be down here at 84. That's where the bar should cut off. And this one should go all the way up to 16, like somewhere in here. So, yeah, good. I also have a second thing I hate about this graph, and it's have you ate any pizza this week, or have you ate pizza this week is wrong. There's a bad sentence. They do state it correctly above, but it should be eaten. So just a note, they say it up here. Come on, program. They say it here, whether they had eaten pizza. So have you ate pizza is totally wrong. I know this is, like, you guys know this, but it just bothers me. This should be, have you eaten pizza this week? Okay, next one. And now I'm only annoying myself more because now I have to throw this away. Okay, good. Number 5. Okay, both of these depict the average monthly water temperature in Hawaii. Which one of these is better than the other? This is one where I definitely think you could argue both, but here would be the way I would look at it. First, I'm going to look for differences. I want to know which one's better. So first, what's different about them? Again, I see interval differences. Like I'll go ahead and label them the same way I did before. Here, interval is 2. Specifically, the y interval is 2. The x interval is strange because it's months, so it's like 1 month or whatever. Why won't it let me just start a new one? I don't like this today. This is interval is 5. So the question is just, in this case, which of those is better? Do we want a smaller interval that shows the changes more, or do we want a larger interval that kind of smooths out the changes a bit? So in order to answer that question, I would be looking at, okay, what is our lowest temperature and our highest temperature here? Or we could look here for the same thing, lowest temperature and highest temperature. Well, now I see one thing that I definitely like better about this graph. That high temperature is 82 and I can see it. This high temperature is like, yeah, sure, 82-ish. I do kind of like that better. But then I would look at this. So 70 to 82 degrees. Well, 70 degrees Fahrenheit, I should have done the math before doing this. 70 degrees Fahrenheit is right about 20 degrees Celsius. And 82 degrees Fahrenheit is about 26 degrees Celsius. Maybe I'm off by a few degrees, but it's going to be something a lot like that. Sorry, I should have looked up those numbers first. So this is 6 degrees Celsius difference from the bottom to the top. Then the question is, which one of these do I think more accurately displays that? Well, in this case, I actually like this one because 6 degrees Celsius is not that big a change. So I like the small change here. But this one does show a bigger change. I can see more clearly that this is 82. I think there are reasons you could argue this graph is better. I personally would choose this one because the range from 70 to 82 is just not that much of a change. So I would want it to look like it's getting hotter, but not by that much. And then this one makes it look like, wow, it really gets hotter and then comes down. So that would be my reasoning there. But you could argue by both sides, I think. This is the first problem where I would be open to that. If you argued both sides, as long as you are arguing based on what you see in the graph, I don't think you could be wrong. So next ones. Okay, so here's one. This is true from my past. I actually brought this statistic home to talk to my dad. The statistic says 95% of all car accidents happen within 10 kilometers from the home. So I was excited. I came home and told my dad about it, and he told me this is useless. It means nothing. It's stated as if it's relating the important information, but it's only relating things that are obviously related. So what does that mean? What is he talking about? Well, let's think about this. If I think about some places I go from home, I don't know, I go to the center pretty often, I go to Maori pretty often, and I go to school pretty often. So for me, if I think about it, let's say this is my home. Well, I live in Yurmala. So if I go over to Maori, well, great, like I'm going to jump over here to Maori, it's close. I live in Bulbari, this is home. So over to Maori, sure, yeah, great. I can also go over the bridge and go to Pinky and go to school. Or I can go over the bridge and go all the way out and go to Riga. And then when I look at, okay, this statistic is talking about within 10 kilometers from home. Well, Riga is like barely more than 10 kilometers from my house. Dang it. So if I draw like this is the 10 kilometer boundary, well, where do I spend most of my driving? When I go to Maori, I'm within 10 kilometers from home. When I go to work and home, I'm within that. When I go to Riga, I leave that space for a bit, but I have to drive through the 10 kilometers close to home in order to get far from home. So I'm driving within this 10 kilometers from home all the time. Well, no wonder 95% of car accidents happen, Like, it's just saying that people drive close to home, and when people drive, car accidents happen. So I do agree, this is a useless statistic. Um, because of that, I would say things like that. I would maybe say, most people spend the vast majority of their driving time close to home. So it should be obvious that most accidents happen close to home. That's what we're talking about. So this statistic isn't necessarily lying, it's just not saying anything. It's making this statement as if it was an important statement. But if you think about it, it's not an important statement. It's useless. So yeah, good. Last problem, I think it's the last one, I forget. Yeah, oh no, two more. That's right. So this one is all about shark attacks. So which state would be the place that shark attacks would happen? Well, and I'm tipping you off, it's the same fallacy as above. So we must be relating here things that are obviously related, shark attacks to state. So let's look, and the fact is, Florida has way more shark attacks than anywhere else. Well, let's go ahead and look at these states, and it should make sense. Okay, well, California here has a lot of coastline. I can see that, like probably shark attacks happen there. Hawaii, it's a set of islands, so there's coastline going around the islands. That makes sense. If we look, Alabama was in there. Alabama has like almost no coastline. Georgia was in there. Georgia has almost no coastline. Texas was in there, and Mexico is not here, but some of this is coastline. Actually, I think all of this stretch here is coastline, but the rest of this is all landlocked. So my point is, shark attacks are not happening anywhere in here. There are no shark attacks there. There are no shark attacks here in California. All the shark attacks have to happen on the coastline, all of them. So when I compare, even California with a lot of coastline, when I compare that to Florida, who has like all of this coastline all the way around, like almost all of Florida is coastline. It's just the whole state is all along that the Bay of Mexico. So, as I was saying, so where do shark attacks happen? Along the coastline. So what state would we expect to have the most shark attacks? Well, Florida has the most coastline. Of course it has the most shark attacks. There's other geographical factors going on. Florida has more shark attacks than we would even expect. But where did my stuff go? Sorry. Well, it's here. Sorry, sixes. And then the last ones. So, sorry about that. So what was I looking for down here? Well, here we're relating things that are obviously related. Like you do most of your driving close to home, so accidents happen close to home. Here we're relating things that are obviously related. Like shark attacks happen on the coastline. Florida has tons of coastline, so it's kind of obvious. Also, California has a lot of coastline. Hawaii has a lot of coastline. You know where it doesn't? Alabama has like no coastline. So this is relating things that are obvious. The last one, both of these graphs depict the population of 5 animals on the endangered species list. Which one of these graphs is misleading? So again, I would be looking for what's the difference between these graphs. And the first thing that I notice in the difference between these graphs is that this one starts at 0 and this one starts at 1,000. So for example, this looks like pandas, like we're not worried about pandas. We're super worried about pandas, but it makes it look even worse than it should be. Where here, like I can see there are some pandas, 0 to 5,000. So maybe there's like, I don't know, a couple thousand in there. But when I look at the difference between starting at 0 and starting at 1,000, I think one of those is clearly misleading. So what would I say here? I would give something like, I would say I choose which one is misleading. Graph 1 is misleading because the y-axis doesn't begin at 0. This makes the bars look shorter than they should be, which is deceiving. Something like that. So those were the ideas I was hoping and thinking you guys would come up with. And that's totally fine. If you had trouble, I know this assignment was really, really heavy on English. Overall, here's what it comes down to. There are two massive things that I would hope you take away from here. One is that your y-axis should always start at 0, like this. Your y-axis should start at 0. The other is that your intervals have to be consistent. Beyond that, we have choices to make. And when we make those choices about what the intervals are going to be, come on, we can make a graph like represent our information better or worse, but these graphs are both sensible, which is why you could argue either of them. These graphs, oh no, not those. These graphs are relatively sensible. I think this one's a lot better, but you could argue both because they use consistent intervals and they started at 0. But if you don't start at 0 and you don't use consistent intervals, then your graph is useless. It's nonsense. It's worse than lying because you are misrepresenting information. I hope this is interesting and makes sense. I'm sorry for a long video, and I'm sorry for an assignment that you guys had trouble with. But yeah, I hope it makes sense. If not, come talk to me. Have a great day, Sixes. Bye.